Some more definitions here. Equivalent sets have the same number of elements or the same cardinality. A one-to-one correspondence between sets A and B means that each element in A can be paired with exactly one element in set B, and vice versa. So we have the cardinality of set A equal to the cardinality of set B. If two sets can be placed in a one-to-one correspondence, then they are equivalent. The cardinality of A does not equal to the cardinality of B. So if two sets can be placed, and we'll do some examples, if two sets can be placed in a one-to-one correspondence, then they are equivalent. Equal. So you have the word equivalent and you have the word equal. Equal sets have the same, exactly the same elements, regardless of order or possible repetition of elements. We symbolize the equality of sets A and B using the statement A is equal to B. If two sets are equal, then they must be equivalent. This is going to be so key here. If two sets are equal, then they must be equivalent. Example 8. Are the sets equivalent? That's part A. And then part 2, are the sets equal? Let's look at letter A. Set A we have is equal to 9, 10, 11, 12, 13. Set B is equal to 8, 9, 10, 11, 12. Are they equivalent? Do we have the same number of elements? Well, let's look at the cardinality. What would be the cardinal number for set A? We have 5 distinct elements. And then for set B, we have 5 distinct elements. Therefore, yes, these are equivalent. But are they equal? Well, you have to have exactly the same. They must mirror each other. So we have 2 9s, we have a 10, we have 11, we have a 12, but one set has 13, the other has 8. So no, they are not equal. Letter B. Set A is equal to, we have 2, 2, 2, 3, 3, 4, 5, and 5. And if they repeat, when you see numbers or elements repeating, we can write it once. We have set A is equal to, we have 2, 3, 4, and 5. So are they equivalent? Set B is 5, 4, 3, and 2. Yes, it's equivalent. Are they equal? Yes, they are equal. Example C. Set A is equal to, for all x is such that x is an element of, my natural numbers notation didn't write out here, so we're going to go ahead and write these out just in case if yours is not written on your paper. Let's look at set A. Let's identify the numbers that's being stated here. What is stated in our roster method. So these are natural numbers. Remember, natural numbers are positive numbers only, beginning with 1 to infinity. No fractions, no decimals. So we're looking at numbers that are between 12 and 17, not including 12, but including 17. So those numbers are 13, 14, 15, 16, and 17. And then for B, for all x is such that x is an element of natural numbers, and 20 is less than or equal to x less than 25. So those numbers are 20, 21, 22, 23, and 24. My question to you is, what's the cardinal number for each of these sets? For set A, the cardinal number, remember the number of distinct elements. How many elements do we have? 1, 2, 3, 4, 5. We have 5. How about for set B? How many distinct elements do we have? 1, 2, 3, 4, 5. We have 5. So, are they equal? Yes. Excuse me, are they equivalent? Sorry about that. Yes, because you have the same number of elements. But are the two sets equal? No, because we do not have the exact same elements. Last terminology, definition for this section. We're going to look at infinite set and finite set. Set A is a finite set if the cardinal number of set A is equal to 0. That is, A is the empty set, or the cardinal number of set A is a natural number. A set whose cardinality is not 0 or a natural number is called an infinite set. So let's take a look at what does infinite mean, what does finite mean. Okay? So finite it means able to be counted, is limited, it has an end, for example, the set of days in a week is a finite set because it only has 7 members, 7 days. Okay? So, we said it can be counted, it's limited, it has an end. An infinite set, think of infinity. Does it ever end? The meaning of infinite. It's unable to be counted, it's unlimited, it's without an end. So example 9, it says determine whether each set is finite or infinite. Example A, the set of natural numbers, and x is greater than or equal to 50. So let's write this out, the roster method. X is greater than 50. 50, we can keep going. 51, 52, 53, we can keep going. It doesn't end. It's not ending anywhere. So out of finite or infinite, which one doesn't end? Okay, so this we would call an infinite set because it's going to positive infinity. Set B, for all x's such that x is an element of natural numbers and x is less than or equal to 2 million. Now remember, natural numbers are positive numbers beginning with 1 to infinity. So if we're saying a set of natural numbers, our set here, when we write our roster method out, it begins with 1, 2, 3, all the way to 2 million. So is this a continuous set, or does this set end? Well, this set does end. You're able to count it. It's limited. It has an end. It ends at 2 million. Therefore, we would call this a finite set.